Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. In this video, we're going to talk about the normal distribution and why we always standardize it. So, different scales, same shape. The normal distribution shows up everywhere in econometrics, but here's something that confuses many students. Why do we always convert everything to standard normal distribution? In this video, I will explain what the normal distribution is and why standardizing is not a trick, but actually a necessity. So, what does the normal distribution represent? A normal distribution is a way of describing randomness. Okay? And that sort of randomness has very particular characteristics. Randomness that piles in the middle and thins out smoothly on both sides. Also is symmetric around its mean. Keep in mind, the mean tells us the center. This is where the center is. And then you've got the variance that tells us how spread out things really are. For every normal distribution to be fully described, you will need two numbers. And usually the mean information is going to be given through the mu and then the variance through the sigma square. When we draw the normal distribution, the peak falls at the center, and this is where we write the mu. Then we move to the left and to the right of the center by a jump that it's called a standard deviation, which we also write as just sigma, keeping in mind that sigma is the square root of the variance, sigma square. So we've moved to both the left or the right with this jump. Okay? So, for instance, if I wanted to distribute, let's say that I assume or I find that the distribution of the income is normal, then I'll find at the center here, on average, the population has an income of, let's say, 30K, and then there's plus and minuses, obviously, because not everyone earns exactly 30K, and this plus minus, let's say, is another 5K, so the sigma being 5K, it means like, well, you've got a plus minus, which gives us 20K and 35K. Now, keep in mind, this is a property of the normal distribution, but within one jump, we have a very clear probability of having these values in here. And most of you will already know that this is approximately 68%. Okay. Now, imagine two normal distributions. So I gave you in here the income, but imagine that on top of the income one, we have a normal distribution for test scores. So obviously, they will have different units, they will have different means, different variances. However, the shape will be the same, this bell curve shape. One might be taller, one might be narrower, flatter, wider, but fundamentally there is one thing that doesn't change, and that is the bell shape. So the problem that will arise from here, though, is that how do we deal with normal distributions for each of which we need to have tables with the probabilities so that I can make inferences? So that would mean coming up one for every test score, one for every income, and another for regression coefficients. Obviously, just using the normal distribution or any normal distribution, it's not going to make your life easy. And that's why you need one universal reference distribution. Okay. This is exactly when standardization comes in, and that's why, as you will see in all of your econometrics books or materials, you will be dealing actually with the standard normal distribution, which has a very particular distribution in the sense like it has very particular parameters. It will have a mean of 0, so it's going to be centered around 0, and it has a sigma, a standard deviation of 1, because it's coming from a variance of 1. Okay, so this now graph that I had earlier on the normal distribution, if I translate it to the standard normal distribution, will finally look like the graph that you see in most of your materials, meaning centered around 0, and then you have 1, 2, 3, 1, 2, 3 with a minus, meaning these are the jumps that you're doing from the mean according to the standard deviation. Okay? Now, this is the distribution behind the Z tables, the p-values, the critical values that you use. So every normal random variable can be transformed into a standard normal distribution type of variable. It's not the scope of this video to really show you where the formula is coming from and so on, but keep in mind, you are centering from a number mu in here to 0. Okay, so it means that this sort of centering requires for you to go from a variable x to a standard normally distributed variable z, let's call it, and this z will achieve it by actually centering at around 0, which means that I need to simply subtract the mean from any of the x values that I see and then divide by sigma. Okay, this will not change the shape, it only changes the units. So keep in mind, again, this part right here of the computation is centering at 0, and dividing it by the standard deviation, you're scaling it, which also means that this is where you're changing units. Okay? After standardizing, you can use the same probability table for everything. Now, in econometrics, you don't really care about the raw values. You want a way to make things interpretable. And that's why we care about like how far an estimate is from the null, or how unusual it is, or how much noise does it surround it. And standardization just helps make the answers to all of those questions a lot easier. So that's why you'll see OLS coefficients are standardized. Test statistics are compared to the standard normal. Probabilities are all read from one single table and not multiple different tables. Okay? So all normal distributions are the same up to shifting and scaling. The standard normal is just the common language we use to compare them. Hope this was helpful to remind you a little bit of like, why do we always see this standardized normal distribution when we always have the mean 0, and why do we always have these like 1, 2, 1, 1, 1, minus 1, minus 2 values in there? Again, keep in mind, is out of the necessity to have a common language for comparison reasons across all the different types of normal distributions that we are dealing with. In the next video, I'll show you how to read actually a table and how to solve exercises by using the Z table. So keep tuned and I'll see you in the next video.